The study of stratigraphy mainly deals with the sedimentary layered rocks. It is important to study the primary structures in sedimentary rocks briefly, and it is useful to do in the stratigraphy as a primer. What is a primary structure? These are the structures not produced by tectonic force or by tectonic stress. Just to mention, stress is force per unit area. Plates can shear past each other leading to strike slip faulting, can go away from each other or can converge. In these ways, several megapascals of stresses can be created and therefore rocks can deform. When we say the primary structures, we are avoiding such structures. So, essentially in sedimentary rock, when the sediments got deposited, whatever structures were produced get preserved, and that is called as the primary structures. We are going to see the common primary structures in this presentation. Starting with bed. What is a bed? It is a sedimentary, beds are sedimentary layers, and by the way, the term bed is the lowest unit in lithostratigraphy. We will see subsequently when we study lithostratigraphy that bed is the lowest lithostratigraphic unit. And how it is produced? It is if the clastic sediments deposited on a horizontal surface, then the beds or the bedding planes are horizontal and mutually parallel. Now, if they are very close spaced, then we call the internal layers as laminations. This is the idealized beds or the bedding planes. Basically in 3 dimension they will look like this. If this is a piece of rock, these are the different layers or the beds or the bedding planes. So, when we look on cross section such as this vertical cross section, we will find this kind of appearance which is even and parallel, but there can be a case where discontinuous, even and parallel pattern can be found. The bedding plane can be wavy yet parallel, they can be curved yet parallel, they can be discontinuous curved and parallel, they can be discontinuous wavy and parallel. Now, in the non-parallel category, they can be even and non-parallel, they can be discontinuous even and non-parallel, they can be wavy and non-parallel, they can be discontinuous wavy non-parallel, they can be discontinuous curved and non-parallel, they can be curved and non-parallel. Nature has so many variations. Now, let us look at another interesting primary structure known as the cross stratification, also known as cross laminations or current bedding. Here, the internal laminations of a bed are inclined to the general bedding or the principal surface of deposition. So, if I make a sketch, this can be the appearance. So, where is the general bedding or the principal surface of deposition? This one is the principal surface of deposition of sediment, and where is the internal lamination of a bed that are inclined? These are those internal laminations. I have already said that laminations are the planes which are very closely spaced, very thin, and here is the actual field photograph where we can see these features. So, if I track and many such layers can be visible, which you can draw. Now, the inclined layers are known as the foreset layers. So, these internal laminations are called So, where are the 4 set layers? Just to point out a few, these are the 4 sets layers. Note that this is a coin. So, you have an idea about the length of the photograph, field photograph, and here is a coin as marker. Now, these cross stratifications can be found in sandstones, quartzites. Quartzites can be the low grade metamorphosed version of sandstones or grainy limestones. Limestone is a non-clastic sedimentary rock, sandstone is a clastic sedimentary rock. Now, the thickness of these units can be few millimeter to tens of meters. Which thickness we are talking about? We are talking about this thickness, which can be few millimeter or few meters. The angle between the foreset bedding and the plane on which the deposition took place this angle cannot exceed 30 to 34 degree. This is because the angle of repose issue comes into the picture for the sediments, and if the sediments are sand, we can say angle of repose of the sand particles. Here this kind of cross stratification indicates a paleo current direction in this geographic direction. In this diagram, in the past water has flown in this direction, and if the cross bedding looks like this, that means in the past water has flown from left towards the right hand side direction. In this case, it is from right towards the left direction. Once I say right to left or left to right, this is informal way of saying. In field, you can measure with a clinometer this geographic direction, and you can say that flow in the past has happened in that particular geographic direction. Now, note that the rock that you are measuring right now is a part of can be a part of a plate, and the plate might have moved or rotated. So, the geographic direction that you are saying here may not be the geographic direction in the past along which fluid flow took place. So, that correction sometimes is required. We are now going to see the ripple marks, and there are two types. Number one is the current ripple mark. When a current of water flowing over a sandy bottom exceeds a certain velocity. Imagine this is the basement and we have sand particles, and here water is flowing, sand particles lying on the basement. Now, if the flow rate increases, then some of these sand particles will be thrown up into, and then they will deposit, and they will deposit in this way, what is known as the current ripple mark. It will look like this. So, these are the sand particles. So, from this asymmetry, we can find out in which direction the fluid has flown in the past in this geographic direction from right towards left, and using clinometer we can find out this direction. This indicates the current flow direction. Can be deciphered. Just like the case of a cross stratification, this is another structure where the paleo current direction can be worked out. Here also from current ripple mark we can do so. Note that a current ripple mark and its inverted form cannot be distinguished. This is important. If you invert this geometry, if you invert it geometrically, you cannot separate this one from the inverted version. So, therefore, we cannot use this to find out the Younging direction. So, if you are just observing this, in the rock, and this is a sedimentary rock, maybe little bit metamorphosed, maybe sandstone has become quartzite. While you can say that the flow direction was this in the past, you cannot say that in this way upward is a Younging direction, cannot be commented. Now, I will take another kind of ripple mark known as the wave ripple mark. What happens in this case? It is produced on the shallow sandy bottom of a standing body. However, water is then agitated by oscillatory motion. That means you have sand particles and the water is static, and then an oscillatory motion of water takes place. Then what happens? These sand particles take a symmetric geometry, attain a geometry in this way. These sand particles attain an overall geometry of symmetric geometry. Interestingly, they develop sharp crests. Where is the crest here? This is the crest area, and that is sharp, sharper than the troughs which are more rounded. You look at the trough region, it is more rounded, curvature is much less over here, curvature is much less over here. So, that is the meaning of this statement. So, this is a symmetric structure and it indicates an oscillating motion. So, it does not give a uniform unique paleo current direction, it gives oscillation, it does not talk about paleo current direction. Note that this does not mean water was static, as I am repeatedly telling, water was oscillating. Now, we take the case of graded bedding. These are the clastic sediments with fining upward succession. This is the bottom, and the first set of depositions are coarse grained sediments, and as you go upward or younging or with time, you are finding fine grained sediment. These are very common. These are most common in the deep sea sandstones which are brought by the turbidity currents. Does it indicate a way up indication or a younging direction? The answer is ideally yes, but be very careful that in nature rarely we find reverse grading. What happens in that case? We get coarse grained materials at the top and fine grained materials at the bottom. So, if you are very sure you are dealing with a graded bedding, then you can say that that is the younging direction. But if it is a reverse grading, this is the younging direction. So, how to distinguish graded bedding from reverse grading remains a question. Reverse graded bedding. Okay. Now, as you see, in case of a graded bedding, sedimentation that happen in still water and the bigger grains deposited first followed by the finer grains, it does not indicate any paleo current direction. Now, let us look at the sole marks. These are produced on the depositional or can be found on the depositional surface. So, this is a depositional surface. On this plane we will be expecting them. They can be elongated depression on the firm surface of mud where deformation is possible. Mud is soft, which is later covered by sand. Let us see, there are, this can give a younging direction since it develops only in the bottom surface. So, since on this surface, on the depositional surface it will develop, it is possible to tell that if I am finding in this way that this is the upward direction, younging direction. There are two types, flute cast and groove cast. Let us start with the flute cast. They are the elongated and somewhat triangular in shape, and that they look like this with a bulging nose pointing up current direction. This is the bulging nose pointing up current direction. So, that means what? In this case the flow is What is the down current direction here? This is the down current direction. Bulging nose pointing up current direction. From here we say that the flow direction indicated from this photograph is towards right hand side. And if we are using a clinometer or Brunton, we can find out the geographic direction. It indicates paleo current direction. It is produced by the scouring action of eddies on the mud surface. Now, we take the second variety known as the groove cast. Grooves are created by hard particles when it moves by flow of the due to the flow of the fluid. It is a kind of tool mark, like the tool. Where is the tool? This is the tool. This produces the down current movement of a mark produced by the down current movement of a relatively coarser object. This is the coarser object on a muddy surface. Why muddy? Because we mean essentially soft surface. And how it looks like in the real photograph, I can track it. We can see in this way, and possibly there are others also. This is the groove cast. It may not be possible to find out the paleo current direction from a groove cast, because we are getting a scratch, and the scratch may indicate flow in this direction or flow in the opposite direction. Load cast, interesting. It is produced by sinking of freshly deposited sand as a series of pockets in a mud layer. Imagine we have got a mud layer over which sand is being deposited. Mud being soft, suppose it has not consolidated, then sand may deposit in pockets. These are the different pockets. And sand will sink, mud will move up. So, mud moves up and produces arrowhead fold. This fold is a primary folding, it is a primary structure. It is not produced by any tectonic deformation. They have round hinge folding over here. So, if I call this as a synform, this portion as a synform, then it is round hinged, and if this is called designated as an antiform, it is sharp hinged. And what is the overall geometry? This kinds of geometry is produced. So, if I find this, I can work out the younging direction. This is the younging direction. Remember, in the field this has to be mud, and this material here has to be sand. It gives a younging direction. Why? Suppose I invert this. Suppose you are finding this, you are getting over here mud deposit, and here you are getting inside sand. That means the layer in the past was not in this disposition, it got completely tilted. So, this is the younging direction. That is why we have said that it gives a younging direction. Let us look at the mud cracks or the sun cracks. When clay rich surface of deposition gets dried up under sun, in exposure of sun, polygonal network of cracks can appear, as is shown over here. It is a very common thing, not just in the geological past, but also we do see in the present day analogues. They are concave upward or skyward. This is the appearance of the mud cracks. They are the way up indicator. So, here this is the way up indicator. Be very careful dealing with the mud cracks or sun cracks and the load cast. You have to clearly distinguish between them. They can indicate a way up indicator. Suppose it after mud cracks are produced and then the mud has been dried up and hardened and later sand comes inside, that is also possible. In cross section the mud cracks can look like this, that means if we are looking at this cross section we may get mud crack appearance like that. So, naturally there is no issue of flow direction. So, it is not a paleo current indicator because no current is involved. In case of load cast, it is not an issue of flow of water and the deposition. So, therefore, load cast is not indicative of any paleo current direction. Now, let us look at structures produced by penny contemporaneous or coeval deformation. During sedimentation deformation happens, then how it looks like. It can produce overturned cross bedding. How it will look like? The foreset layers can be isoclinally folded, which is shown over here. So, this is the place of the overturned cross bedding. We are not talking these as overturned cross bedding, but rather the top portion has been called. Here is a scale for your reference to give an idea what is the length of the photograph in the field. Isoclinally fold means tightly folded. Convolute lamination, all kinds of intrastratal folds of penny contemporaneous origin, individual layers can be traced through a train of folds. I can see it is a train of fold visible and is broad rounded syncline. You can see these two portions clearly indicates that they are broad rounded synclines, and then there are sharp anticlines where it is, or sharp antiforms where it is these are the sharp antiforms. Often shows sharp truncation at the erosional plane. For example, these folds got terminated over there. So, it is a truncation is visible. Slum structures are produced by downslope sliding of a mass of unconsolidated sediments. Now, having said this, I am requesting the viewers to make a list of primary structures that I have described here indicating of paleocurrent direction and a list of structures which do not indicate paleocurrent directions. Then make another list of structures which indicates younging up direction and another list of structures which are not indicative of younging upward direction or the way up indicator.